have to have, and also with the communication, they really have to know their subject.
Well, have you all survived the summer?
Very well.
Start.
Go.
Age 66, when many are retiring, Hawking shows no sign of giving up the quest.
The food's improved since I was a student. Has it improved the work rate of the students?
No.
I think it's inverse proportional.
Hawking's life's work has been to come up with a theory of everything. A theory that explains how our universe works and how it arose. In the 1970s, he had huge success using the theory of the tiny, quantum mechanics, to better explain black holes. But in the 30 years since, using it to explain the entire universe has turned out to be just a bit harder.
Nevertheless, even though the job has been more difficult than one might have hoped, I think there is still every indication that there is a final theory and that we may get there, but it just proves much more complicated than we originally hoped.
Not surprising, really, that it's been hard. Hawking's trying to peer back to 13.7 billion years ago, to the start of everything. His main stumbling block has been getting the theory to explain what the entire universe was like back then, when it was all compressed to a size smaller than an atom.
Although the universe is very big now, the observable universe is something like 13,000 million light years, the distance light has traveled since the Big Bang. We know that that entire region must once have been compressed into a very, very, very small scale. But of course, once the universe is compressed into a very, very small scale or a very, very high density, we know we are in the domain of quantum theory.
But even though the universe was once tiny, the amount of energy and gravity that it contained was vast. Getting the theory of the tiny to explain that huge level of gravity has proved impossible so far.
If we want to know what happened when the universe began, we have to have a theory that can describe gravity on a very small scale.
For the last 30 years, Hawking has struggled to find a way to describe immense gravity with quantum theory. But he has faith that the theory of the tiny will eventually win through. And there's evidence that supports his belief. Just as atoms are fuzzy and erratic, it seems the universe was too, when it was tiny. And the evidence comes from satellite observations of the heavens. Since the late 1960s, scientists have known that there's leftover heat radiation from the Big Bang. It's a tiny amount, but recent satellite missions have shown that this leftover heat is not smoothly or evenly distributed throughout the universe. WMAP is the latest satellite to refine our picture of this echo of the Big Bang. Dave Spergel is part of the WMAP team.
What WMAP's seeing is variation in temperature of a few millionths of a degree. That results in more matter being here than over there.
WMAP supports Hawking's reasoning. This is the image of our universe today, which WMAP has produced. The colors indicate tiny differences in temperature. If Hawking is right, the differences started right when the universe was the size of an atom. This picture is like a massive projection of what was going on at the beginning of everything. The universe was uneven or fuzzy at the start, and that unevenness has evolved into the different parts of the universe we see today.
That may not sound that important to you, but because there's more matter here, a galaxy is going to form here, and we're going to live here, and there'll be nearly empty space here. By studying the properties of these fluctuations, we can learn about the quantum mechanical fluctuations in the very early universe that gave rise to what we see, and us.
Without tiny quantum fuzziness affecting the Big Bang, huge galaxies would never have formed. A perfectly spherical explosion of time and space would not have done the job. It is the roughness of the moment of creation that gave rise to matter and galaxies. As Hawking suspected, we live because of the imperfections of creation. Hawking is forging ahead on his quest for a theory of everything. Today, all of physics is racing alongside him. Incredible experiments are now being built in outer space and deep underground, which will try and probe deeper into the very moment of creation. There is excitement in the air, a sense that the answer is just waiting to be found. Whether he finds it first or not, Hawking is philosophical about his part in this great journey.
I was unlucky to get motor neuron disease, but lucky in almost everything else. I have 3 very attractive children, success in my scientific work, and a real sense of satisfaction at having achieved all this, despite the difficulties. Not many people can say this.
Is there anything you wish you'd achieved professionally, perhaps, that you haven't already?
I feel I have achieved quite a lot, but one would always like to have done more. In particular, I would like to have found a complete theory of quantum gravity and the early universe. Still, that wouldn't have left much for anyone else to do.